you have to work with radians to find coterminal, or to draw the angle, all that, the easiest thing to do is whenever you have a top-heavy fraction like this, rewrite it in terms of a mixed number.
Yes.
Okay. So 12 goes into 19 once, and there's 7 left over. So think of it as this. I think someone in third hour said, can we write this as 1 pi and 7 pi over 12? And I said, yes, that makes total sense. Okay. So when you want to draw that, we know that 0, 1 pi, back here is 2 pi. So I know it's got to come around past 1 pi, but then I have to figure out 7 over 12. Is 7 over 12 more or less than halfway? More. So that means it's got to pass the halfway point here. Okay? So this is going to be my 19 pi over 12. Okay? Now, what I was asking you to do was write down how much further do you have to go to get to the x-axis. Your reference angle here would be 5 pi over 12. Okay? I'm just getting you guys in the habit of doing that. This is all practice to write that out. Okay? Does that make more sense?
Yes, sir.
Okay. The other one you said was what, 34? Okay. 34. It's negative 5 pi. So the same idea. So you have negative 5 pi. This is when you get to count pi. It's negative, so you have to go the other way around. So ready? Here we go. 1 little, 2 little, 3 little pi. Here. 5, 4 little pi. That's how.
Oh my God. That's 5 pi. That's negative 5 pi.
That's negative 5 pi. Okay. When you're on the axis, you are on what's called a quadrantal. We talked about that term yesterday.
That's what it was.
What?
Quadrantal. Quadrantal is when your terminal size lies on the axis. Okay. There's something important about those that we'll talk more about. Tomorrow. Where's it today? I don't remember. I think it's tomorrow.
I'm back to there.
Right. How'd you do with coterminals then?
We do all this over.
Sure. Which one? Okay. So 38, we have to find coterminal angles. It was at 420 degrees. Okay. Now, 420 degrees is beyond 1 revolution. Okay. So what I wanted you guys to do, I want you guys to start visualizing what it looks like as you go around. So we know we've got to go counterclockwise. There's 360. So now I have to figure out how many more degrees do I have to go. Well, I back out to 360 because I've already done that. And when I do that, I'm left with 60 degrees. Okay. So now that means I just go into the first quadrant 60 degrees. Okay. So when I have a positive and a negative coterminal, if my given angle is beyond or beyond however many revolutions of degrees or pi, I need to bring it back into 1 revolution to get its first positive or its first negative coterminal. This means that 60 degrees is its positive coterminal angle. Okay. I back out 360 again, and I get negative 300, and that would be my negative coterminal. Again, if you do it visually, if I go this direction, I'm 60 degrees off of 360, going negative. So that means I went negative 300 degrees. Okay? That's why I like to draw them out to show the visual part of it. That's why using that little reference angle, it works out. Bless you.
Thank you.
Yes, ma'am. 42. Bless you. What's the angle? 24 pi over 7? Okay. Same thing. Before we do anything, I want to convert that to a mixed number. Okay. 7 goes into 24 3 times, and then there's 3 left over. Okay. So we have 3 pi and 3/7 pi. All right. So what we need to do is figure out where does this land first. So it was positive. We got to count pi again. So ready? 1 little, 2 little, 3 little pi. Now 3/7 is 3/7 is 3 more or less than halfway of 7? Less. And that's the trick. You just check that value there. So it's less than halfway, so it's somewhere in here. Okay. Now, excuse me. That means that what we need to do is figure out its positive coterminal. Well, its positive coterminal would be, since this is beyond 2 pi, all I have to do is back out 2 pi. I'm left with 1 pi and 3/7 pi, which is, as you bring this around, well, there's 7/7 plus 3/7 is 10 pi over 7. Okay. Oh, real fast, before I get too far, how far was that off of the x-axis? What was the reference? 3/7. Good. So this little reference here would have been 3 pi over 7, because that's how much further it was dropped down. Okay. There's my positive. To do my negative, we're going the other direction. I'm going this way. Well, if I know from negative from here to here would be negative 7/7 pi, I'm off the x-axis by 3/7, which means I'm at negative 4/7. Okay, yes, sir. Great question. Again, you could also have done the same thing. You knew that this was the positive, and you had to subtract out 2 pi. If I subtract 2 pi from this, it's 14 pi over 7, and lo and behold, what do you get? It's a lot of common denominator work when you get to the radians. Okay? It is a lot of common denominator. Is that defogging a lot of it?
Yeah.
Yeah, coffee's delicious. So we left off yesterday then. Standards, this, coterminal. Don't worry. We did that one. Oh yeah, how'd you do with conversions? You okay? Converting radians, degrees, radians. Oh, yeah, written down. How would you have all your notes together?
We're all
Exactly. You multiply by 180 over 5. So if you've got to go the other direction, think of it this way. Radians always have pi in it. You want to get rid of pi. So if you have to get rid of pi, if I have like negative 9 pi over 2, and I want to write that 2 degrees, I'd have to multiply this one by 180 over pi. And then you start working on fractions. 2 goes into 180 90 times. 90 times 9 is negative 810 degrees. You will not get calculators for this stuff, guys. You have to know how to simplify and work with fractions. Okay? Gotta know how to simplify and work with fractions. Hi. Which one? Uh, 400. Okay. So converting 400 to radians. Multiply by a pi, divide it by 180. Okay. Easiest thing to do, drop a 0. 40 and 80, they're both, or 18, they're both divisible by 2. So that would be 20 pi. Oops. You're done. Oh yeah, today's Thursday. I forgot. Is that what you're saying?
Yeah.
Because what time would that have gone off?
8:06 or 8:12.
8:12. What's that?
It's a little bit before 8:06, so we're still at time. It's 8:01. Is it about usually going up?
No, remember last Thursday we had the early release? Yeah, I know. It seems like
That was
so
last
long.
Thursday.
I know, right? If you guys just leave, I don't think if everybody left, what are they gonna do?
They can't stop us.
It's like Animal House and Kevin Bacon going, all is well, and he gets run over. It's just not gonna happen. And what if we
Honestly, that's just
Are they gonna fail all of us? We all see the
that area arc lengths and areas. This is that last little bit. This is also a quick little tie-in to some of the things that you guys did last year.
why do you bring this save 100 pounds?
This is how you guys work. You guys already did ratings last year. You just didn't know you did it. You did arc length. You were doing ratings.
I don't like her.
I don't remember how to do it.
Well, like I said yesterday, when you guys dealt with arc length last year, when you had a circle, you had a central angle, and you're trying to find the distance on the curve.
Yeah.
Well, the distance on the curve dealt with part of the circumference. Okay. So what you did is you figured out whatever the angle was. You knew the angle, you knew the radius, you knew how to figure it all out. So last year, what you guys did is you took central angle over 360 times 2 pi r, because 2 pi r was in fact circumference. So you're figuring out the ratioed amount, how much of it do you have to go all the way around. That's where all this came from. Now, depending upon, more often than not, what we did is we just left it like this. We didn't worry about simplifying, because you guys were using the calculator and all that. This can be simplified right away as theta over 180 times pi r. And that's how you get that. Okay. Now, what this whole portion is, this is radian. Theta times pi over 180 is radians. Okay. So what they do is, instead of using theta over 180 pi, this is equal to what they call S. That means it's the theta value in radians. Okay. That's what they're using that for. Okay. So what happens here is that we get. I'm sorry, I have that backwards. What they do is they use it arc length. They call it S, the semi part of the circle, whatever. They use it radius times theta, where theta is in radians. Okay. So instead of it being angle, I might map stuff backwards. It's theta radius is your arc length. And they call that S. Where theta is in radians. That's all that meant. You guys did this before, it's just a different way of writing it out. Okay. So when you find your arc length, if you're given a central angle of degrees, just convert it and slap the radius next to it. Simplify your fractions. Okay. That's very, very simple. The other thing that you guys did last year was when you guys did area of a sector. Remember, area of a sector was, oh God, that's terrible. It's this piece in here. I appreciate the encouragement. So the area of the sector was portion of the area of the circle. Same basic idea here. When you have area of a circle with pi r squared, and in this case it was some part of it. Well, again, what we're doing, we're finding the portion of it by using radians, where you wind up with the formula 1/2 radius squared times theta. Again, where theta is radians. Okay. To get the area of this, it's going to be 1/2 radius squared theta, where theta is in radians. Okay. That's why we practiced a little bit yesterday about converting from degrees to radians, radians to degrees. You use it pretty often. Right? As far as the fractions and stuff are all concerned, when you multiply these things out, they're usually nothing too extraordinarily difficult. They're usually fairly straightforward where you don't have to worry so much about it. As you saw yesterday with some of those conversion ones, once the numbers get really kind of crummy, even when you're going radians to degrees, you want it simplified as you go through. So it's just a matter of practice of divided by 3s, divided by 2s, and all that. If you're looking for GCFs and stuff. Yeah. So let's look at an example. For each of these things, I'm going to do both the rate. I'm going to want to find. What's that? Oh. I want to find both. I give you theta. Do that will make this more difficult. So let's do arc length and area of the sector for that didn't work. Now let's do this. Radius was 4, angle is 200. We're going to do both arc length and then area of the sector. Okay, we'll do both. So the radius is 4, the angle is 200. So the arc length is going to be theta times the radius, but we need to get theta into our angle into radians. So we have to start with 200 pi over 180, and then it's times 4. When you write it out, that's what it should look like, because you're just automatically converting and going from there. Now, it's a matter of simplifying. Okay? And this is where the easy part goes. We start taking zeros out. 4 and 18, they're both divisible by 2. So you have 9, 2. And here, you'll notice you get 40 and a 9. They're not going to do it any further. So your final answer would just be 45 over 9. So there's your arc length. It's actually the same thing.
Oh yeah, I'm talking, yeah.
This is the exact same formula as what you guys did here. Not even. Your only thing different between here and here is that last year you guys wrote it as 2 pi r all the time. What's 2 and 360?
Yeah.
We didn't do it like that last year because we want to mess you guys up because we want you guys thinking of circumference all the time. So, okay. And then area of the sector, again, same idea. 1/2 the radius squared theta, so we just got to, again, put it all together. We wind up with 1/2 4 squared, and then our 200 pi over, what was it, 180 for that. Okay. From here, it's just simplifying. Okay. Right off the bat, I know it's going to be 16. Oops. So I have 1/2 times 16 times 200 over 180 times a pi. Spread it out a little bit and make your life really easy. What's the first thing I'm going to get knocked out? A 0. But get rid of the 0. Okay. What's the easiest thing to get rid of now? The 2. The 2 and the 200. And the 2 and the 20 become 10. 18 and 10 or 18 and 16, does it matter which one I simplify? If I simplify 18 and 16, they're both divisible by what? 2. This becomes a 9. This becomes an 8. So you have 85 over 9. When you're simplifying those fractions, take your time. Because you don't have a calculator. You can try to. Same idea. Arc length. Take a second and try them with that one. I gotta yell at you if you forget to label.
Yeah. Yes. I think you're like the worst.
Honestly, it's not that big. I mean, I get it. We should. I get it.
Train? No,
Am I going to give you these formulas ever? No. No way, Jose.
Sucker.
Yes, sucker. Right. Your heading, your header on there checks out. Well, then your header. So our planes again start out. We have to do angle 180, 5, and our radius. What's up? If it's in degrees, that means it's not in radians. Okay, if it's in degrees, it's not radians, you have to convert it to radians. Okay. I forgot that, I didn't realize that this book did that. For all these years using the same book, I think I figured that out. But anyway, so in this case, start simplifying things out. 15 and 180, or how many times is 15 going to 18? Once on your left over. 3. So 15 goes into 1 and 18 here is once with 3 left over, so 2. So 15 goes out and becomes a 12. Does 12 go into 175? All right, well, do you know how to check if they're both divisible by 3? Yeah. What's 1 plus 7? 8. What's 8 plus 5? What's 3 plus 1? 4, so it's not divisible by 3, is it?
I'm confused on
Things are divisible by 3 if you add the values together and the sum is divisible by 3. What's 1 plus 7? 8. What's 8 plus 5? 13. Is 13 divisible by 3? You can also do 3 plus 1 and it's 4. It still doesn't work. Okay. So I know that you'd be done in 175 pi over 12. Okay. Sector, same deal. We have 1/2. Radius squared, 15 squared. And then we have our theta of, 175 over 180 pi. Let's see, 15 squared is what, 225?
Yeah.
Not really. I don't have that big of a sweet tooth, to be honest with you. My wife brought home some of those nothing fun cake things, and I was like, I don't know. Even if now,
They're nice snacks.
I don't know. I'll have a piece of, like a small little piece of chocolate from once, but I'd rather have a bag of chips.
Oh, so you're more like
The salty. Yeah. This one here really looks like the only thing I'm going to be able to simplify some of the 5s. 175 and 180, they're both divisible by 5. I know that. So 5 goes into 17 3 times, 2 left over, so it'll be 35 for that one. Which means this one would be 40 because it's 1 more. No, not 40, I'm sorry. That's still 5, would be 3. 36. Yes, good morning. Math is strong with me today. And then here, the struggle apparently is real. I don't see anything else I'm going to be able to simplify, so I know I'm going to have 225 times 35 over 72 with a pi next to it. Which means I got to figure that out.
Yeah.
Let me just double check this here. Oh, 2 plus 2 is what? 4. 4 plus 5 is 9, which means 9. I can do it threes with the 225 and the 72. Okay. Yes, ma'am. 2 times 36. The denominators multiplying together. So here, if I divide this one by 3, I'm going to get a 224. This one divided by 3 be a 75. You okay with that so far? Okay. 75 and 24. Well, what's 7 plus 5? 12. What's 2 plus 4? 6. Which means I can do 3 again. Okay. So if I do it by 3 again, excuse me, I'd get 8. And this would be a 1, 2, wait, yeah. No, 2, sorry. 25. So now I have 25 times 35, 5 over 8. So now I'm pretty much done simplifying, so now all I have left to do is multiply the two numerators together. So I have 875 pi over 8. That's the downfall with some of those. If the given theta value isn't as clean as some of the other ones, it can be kind of messy. I'm sorry to put you out on that one. What's wrong? Well, it's good practice. You okay?
Yeah. Yes, I won that. Oh, yeah, did good. I didn't win anything.
You won our admiration.
I won, not
really.
I won 1 predetermined point. You won. No one asked. I know.
I'm trying to make everything happen.
Yeah, we gotta have to.
I thought that was different. Yeah. So I remember. Okay, I remember. Because we had no school.
I don't understand.
Dude, it's what do you say?
Oh, sorry.
Yeah, you're right. It was 2 weeks ago. Hey, you're wrong, Xander. 2 weeks ago, we had a half day. So, yeah.
Wow, so you forgot about it.
Yeah. So you're a day late and a dollar short. I'm always right. Oh, I was always right. Oh, sorry. Okay. So on this one here, guys, this is all basically the exact same stuff you've been doing. When I'm asking you guys to draw these things in those standard positions just like you were doing yesterday, always try and find that reference angle as well. I know there's way more on here than what we need to do, so I would just say pick a column and go through them. The what I'll do later on is the CUDA stuff has just a generic back page of the answer. I'll throw the answer stuff up on the calendar so you can check and see how you did. Remember, the CUDA stuff isn't asking you to find the reference angles. I am, so you're not going to see some of those values on there, so it won't be that big of a deal. Okay? You got time, you got questions in the style, ask away. Good times had by all. That helps.